Hi. Told some of you I was going to try a video, so this is going to be pretty low tech, but here we go. Chapter 6, right? You guys are working on a confidence interval. So again, remember, a confidence interval, what you're trying to do is find a minimum and maximum for some interval. And to do that, you start with this point estimate, and that point estimate, that's right in the middle. Okay, so now so it's a midpoint. So in 6.1 and 6.2, that point estimate is just as X bar, the sample mean. So you're just given that. Okay. In 6.3, it's p hat, which is a proportion. Now you've seen p before, proportion or percent. So again, just a reminder, what's p hat? It's, for instance, what proportion of the population said yes. So maybe it's like 50% or 60% of the population said yes. Then p hat would be 0.6 for 60% or 0.5 for 50%. Okay, so sometimes that's given directly to you. If it's not, then you just use this little formula, which it's basically just a percent, right? So you take how many said yes, and if it's what proportion of the population said yes, over the total. So let's say it's 60 out of 100 people said yes. Well, 60 over 100 would be 0.6. So you need this point estimate. Again, sometimes it's just given right to you. Sometimes you have to do a little work to get it, not much. Okay, but then what? Well, then, we need to find this minimum and the maximum. Now, some of the problems you can just your calculator find that for you, and other times they have you find that. But to do that, to get to the min and max, if you have to do it more by hand, is you have to find margin of error, and they use that nice big capital E for that. So that's margin of error. And when you found that, okay, if you know this midpoint, what you do is you add that margin of error to get the max, and you subtract it to get the minimum. Okay, and we'll do well, I'll show you the formulas to come up with that margin of error if you have to, but most of the time in the homework they have you maybe find parts of it. Okay, but where are these formulas for finding margin of error? Well, to do that, let's go to the sheet here. Okay, so here's your key formula sheet. Okay, so and let's pull this down over here. Okay, so finding margin of error, the formulas are in your gold key formula sheet. So right, let's look there. That's what we're doing. Okay, so let's see here. This thing's split up like this. This is all 6.1 and 6.2. Now in 6.1, for 6.1, if you're looking for margin of error, it's this formula right here. And 6.2, this was your formula. And again, notice, right, here they're doing, getting out of focus, Z of C, right? Z-score. T of C, T-score, right, or your critical values. Okay, in 6.3, this is your formula. What I want you to notice is that here out front, right, they have that. So like in the homework, they might just have you find that, right? Or maybe they have you find the whole margin of error. So, but these are the formulas you would use. So you need, right, your critical value, Z-score here, standard deviation, how many numbers in the sample. Here you need T, and standard deviation, and how many numbers in the sample. Down here, you need Z, and then P and Q. Okay, so P and Q. Well, P and Q, that's the p hat, right? That's the probability of success. Q's probability of failure. So if, for instance, if 60% of the people said yes, that's 0.6, then that means 40% said no, that's 0.4. 0.6, 0.4, they add up to 1. Okay, and then also the number of numbers in the sample. Okay, so here's where we're at right now. We're looking at, you need to find these critical values, and you might have to do that in the homework, right? So 6.1, Z, 6.2, T, 6.3, Z again. Now there's one thing though. They say in 6.3 that you can only use Z if these two things are true. And you've done this stuff before. N times the probability of success, is that greater than or equal to 5? And then N times probability of failure, is that greater than or equal to 5? So see, it's N times 0.6 and then N times 0.4. Okay, now if this is true, right? Both those are over 5 or greater, then you can use the Z-score. A lot of times they ask you that before you go on and work the problem all the way through. Okay, so next. So again, you might need to use these 3 formulas here to work through things. Okay, but now what about how to use your calculator to find these confidence intervals? Okay, so let's go to that. And to do that, here, let me just pause things a second. Here's what we're going to do. Okay, so finding confidence intervals for population proportions with your calculator. We're going to look at examples 1 and 2 first. Okay, on pages 327, 329. Okay, examples 1 and 2. Okay, so why 1 and 2? Well, example 1, they give you the numbers you need. So the numbers you need are right here. Okay, there's your sample size. There's the number of people that said that it's accessible to look at your personal email at work. Okay. Now, they didn't give you P directly, right? So notice they take the two numbers, they divide, and there it is, 0.662. Okay. So now, if you're using your calculator, though, you don't have to actually go through all that work. But if you were doing one of those formulas, then you would. Okay, but let's go. So we need those numbers, but now let's go to the example 2. Okay, where they continue things. Okay, sorry. Okay, so it says use the data from example 1 and find a 95% confidence interval. Okay, for that situation, for the proportion of U.S. adults who say it's acceptable to check personal email at work. Okay, so they're doing a lot of work here, right? To get down to right here, this is what we want. See, there's that min, there's that max. What's in the middle, right? That's your midpoint, or your so your p hat right there. Okay, but how do we do this on the calculator? So here we go. So on the calculator, where you go is stat, and then test, and then it's down at A, right here, 1 proportion Z interval. Okay, so when you get here, just go here, and what you would do is just put in your numbers, which if I remember right, 662 and 1,000. Now this one works out really nice because see this number right here, it's integer, no decimals there. It'll give you an error, and we'll have to talk about that. We'll do one more example to talk through that. But there, the confidence level is right. But notice that's all we have to do. And then when we hit enter, there's the min, there's the max. Okay, there they are. There's your confidence interval. And then what do they say? Okay, with 95% confidence, you can say that the population, not the sample, but the population proportion of U.S. adults who say that it's acceptable to check personal email while at work is between about 63 and 69%. Okay. Now next we're going to do example 3 because there's an issue here. and you'll run into it with the homework. Okay, so let's turn there. And here they have a diagram of some cars. Who are more dangerous drivers? Most people say you guys are. I think that's true. Teenagers, just awful drivers. Oh my word. They should get more tickets. I just don't know, you know. But look at that, people over 65. So I'm not over 65 yet, so I'm a very good driver. See, I'm in this 4% right here. You guys are in here. Man, that's terrible. Well, anyways, so they say they want a 99% confidence interval for the population proportion of U.S. adults who think teenagers are more dangerous drivers. Okay, so we're going to look at this one right here, the 71%. Okay, now the survey was 498. Okay, so here's what we got to do. Okay, so we're going to go back to stat, test, and go down to A again. Now you can just hit alpha A if you want to. Okay, so 498. That's total. Okay, now what about this? It was 0.71, right? 71% of that 498. Here's the issue. We get a decimal here, and what it's going to do is it would give us an error. Now they want a 99% confidence interval, so 0.99. Okay, so if I calculate, it's going to give me an error. But I'm going to go up here. Here's what I found, is that if you round up, not round, but round up, so I'll go to 354. And now I'll calculate. And when I do this, it will work. You're going to see it's 659. It's going to, they're rounding to 3 decimal places. So this would be 659 and 763. And you can see that they're off by 1/1000th. But when I did a problem in the homework, it was fine with that. Okay, that I was that close. Okay, I was able to be within 0.001, and then it was just fine. So then the only other thing to talk to you about is they're going to give you some problems where they ask you to find minimum sample size. Now, to do that, you've got to use the formulas on the key formula sheet. That's the only way to do it. The other way is guess and check, and that would take you forever. So where are those formulas? Well, you've already used one of them right here. So n is the minimum sample size. Well, now down here in 6.3, here's the formula. Okay, so remember, you'll have to find this z-score, and then there's p and there's q, and then they'll give you this margin error. They might say like 3% margin error, so that'd be 0.03. But this just made me think of one thing that it would be good to mention to you when you're looking for z of c or t of c, etc. Okay, so I went back to 6.1, and you probably already know this, but just in case, if you're looking for a critical value, see right here, and here, okay, you need to either use inverse norm or inverse t, right? So, and we'll just remind you when we're done talking here about how do you know which to use? Okay, well actually we already did. We did right here, right? So when you're looking to find those critical values. Okay. So, but what do you need to do? Well, here's the deal. This is a 95% confidence level, right? So how do we do that? Well, this is section 1, so we would go to distribution right here. And we would do inverse norm, because inverse norm is z. And we don't put in 0.95, okay, we either put in 0.25 or we put in 0.25 plus 0.95. So right now I have the two added together. So I'm going to do that one as long as it's there. There it is. So you see I'm getting that 1.96 that's at the top. But what happens if I put in 0.025 instead? Okay. I just get the opposite, right? I get that bottom one. But now, you always use positive. What I do is I'll put in the 0.025 and I'll just go, okay, but I need positive, not negative. Okay. Okay, so then if you're doing t, so here's one for section 2, you're doing t. Well, now you run into the degrees of freedom thing. So it's 95% right. So let's see what happens here. I'm going to go back to here, but now I'm going to go to number 4, inverse t, and the area, 0.025, ends up being the same on the bottom, but then it's got this degrees of freedom. Well, where does that come from? Well, that came, in this problem, it came from up here. N was 15, so we subtract 1, and that's degrees of freedom, 14, and when I put that in, there it is. See how it matches up there, but of course I'm going to use the positive one, right? Okay, and the reason why you're doing degrees of freedom, and I'm not going to explain this, but what they're explaining there is that a t distribution is close to a normal. So that's why they're subtracting the 1. It's not going to be exactly the same as normal. Now when you get to 30, right, a big thing is if you have 30 or more in your sample, you can always use z, but if you have less than 30, you're going to use t. So hopefully this all helps. Let me know what you think. Thanks for all the replies to the discussion. It was good to hear from people, and hope the work goes good for you.